I'm John Murray. Most of you probably don't know me, so a little bit about myself. I work on developer experience at Antithesis, where I help make internal tools to make our developers make software that works so you can use our product to make your software work. I've been a Nix shill for many years now, and this picture is me basically anytime I see Nix mentioned online. I just absolutely love Nix, and I've loved talking about it. And when Isaac was telling me what I could talk about here at this conference, he said, feel free to talk about Nix. So if any complaints, the shilling gets too hard, please direct all complaints his way. But to be real, this conference is about software reliability and it working. And I believe one of the best ways you can help yourself and your team get working software is through reproducibility everywhere. So if you have reproducibility at all layers of your stack, that helps you make better software. If you can reproduce any bug you found, you have basically infinite chances to fix it. If your developer environments are reproducible, you're less likely to have the dreaded "it works on my machine." And if your local environment is reproducible in the cloud, you can be much more confident that your changes that you tested locally can actually work in production. And to hit this harder, if you have a reproducible developer experience, devs spend more time doing the things that actually matter, like testing, going through all the processes. They'll be spending less time fighting their environment. They'll get faster feedback loops. And hopefully you have a sane golden path that all the developers are using. They're not relying on random readmes or old company lore of how to get something done. It's all checked into the repo and will be used by everyone. So the things I'm going to cover in this talk is how using Nix we can get reproducible developer environments, reproducible actions, and reproducible cloud deployments. So just a show of hands, how many people have actually used Nix at all? OK, sick, a good amount, cool. So first, let's just look at some Nix code, and we can go from there. But Nix at a high level is a programming language, a package manager, and an entire Linux distribution. So in this case, this is kind of all the different syntax and things you can do in Nix. You can declare variables, write functions, make objects, import other files. And it's basically if Haskell and JavaScript had a baby. You have a pure functional language with laziness, but its type system is basically non-existent. It's all runtime. But the reason that you want to use Nix is that it provides reproducible builds, and you can use that to build an entire stack to make your entire process reproducible. So at the bottom is a very simple Nix build. You just can echo an output of this is a build to a special output file, and Nix will track it all for you. But to make builds reproducible in Nix, Nix will track all of the inputs to a build, including the recipe itself. Each build gets its own unique immutable output that is tracked in the Nix store, which I'll show in a second. And each build runs in a sandbox with very limited network access and a standardized environment. And when you hear the word sandbox, it might be like, isn't that for security? But I think sandboxing is one of the main ways you can have a reproducible environment. The more and more you know what is around your code, the more likely that it's going to behave the same way every time. So this is like how you would use the Nix language. What does an output look like? So in this example, this is the Git binary that you would produce with Nix. And the first thing you can see there is a little hash. And so that hash is every input that the build of Git needed. So if you change anything in that pipeline, you're going to get an entirely separate output. That way you can have, say, 40 different copies of Git on your machine, and they'll all be behaving independently and won't be clobbering each other. And second, Nix makes sure that every dependency that build is using is explicit. So if you run LDD on the Git binary to see all the different dynamic dependencies it needs, Nix pins them to explicit other paths in the Nix store. So it's not depending on any global state in your system. It's using explicit references, so you'll always behave the same. So if it's working on my machine, it'll work on your machine. And I think a lot of people, this is as nitty-gritty I'll get with Nix. I'll kind of from here just showing you how you can use it to make reproducible environments. So I think everyone's first step into Nix is probably through NixOS. And NixOS is really sick. So this is a very simple NixOS config, which helps you have an entire Linux distribution for your system. And in this case, we are setting up GNOME, maybe getting Podman for a container runtime, and installing some packages onto your system. And under the hood, we'll take this definition that's a very declarative style, very infrastructure as code kind of vibes. And it'll create systemd units, symlink files from the Nix store for different config that programs might need. And it just makes this whole declarative config a reality. And one of the really cool benefits of this is that at the end of the day, there is one build or derivation that defines your entire system. So one NIX output is your entire computer. And this means you can roll back to previous versions. And let me tell you, this is one of the best things to do with NixOS. So just because your config is declarative doesn't mean it actually works. Many oftentimes I'll be playing with my config and say, oh, I want to switch to a different desktop environment or try some new program. I go to load the new config, and then now my networking driver doesn't work, or my keyboard stopped working, or my GPU driver is all screwed up. But on a normal Linux distribution, that would be a giant pain in the ass, and you have to edit files from a TTY or something. But in Nix, it's fine. You just turn it off, reboot, and you can go back to the old version, and it's like it never even happened. And since it's all in code, you can share config very simply and easily. At Antithesis, we have a shared module that all of our developers use, and I can roll out updates to everyone, and it should just kind of work on all their machines. For example, at Antithesis, we had to roll out a VPN that was kind of custom and had to hook into a lot of internal services. And I just had people pull the config, run an update, and everything just kind of worked. I didn't have to tell them to read like a 30-step document of how to do everything. It was just pull the code, rebuild, and everything just kind of deployed. But with that said, it's not a silver bullet to just use NixOS. You can't just trust that everyone in your team has the exact same Linux distribution everywhere. People want to customize their setup and use their own different tools. So we don't want to force them to have the same config. So how do we actually make this work on a project level? And just to have like a basic idea of like a project you might be working on, let's just say for fun we have like a front end in TypeScript, a back end in Rust, and maybe like a Postgres database. Nothing crazy. Don't really worry about the internals. Just know this is what we're working with. So if you take anything away from this talk, if you're not a Nix head, is just set up a Nix shell. So at the end of the day, a Nix shell will help you specify all of the different dependencies that your project needs. So since we have front end in TypeScript, we need Node.js, we need Cargo and Rust C for the back end, and we can even have all of Postgres as well in our Nix shell. And all you have to do is when you're using this shell is when you're outside of the shell, you have nothing. You don't have Cargo or NPM or whatever. You can activate the Nix shell, and then now you have Cargo and NPM pointing to explicit Nix store paths, and then you can use the tools as normal. And this is honestly a great 80% solution to get reproducibility everywhere. It's like using RustUp or MVM or the 1 million different version managers that you might be used to, but it's all one tool to configure every tool your system might need. And it will work forever. So if you come back to this project 6 months later, you'll have the same exact developer environment. But this is great. This is just using the normal tools but how do you get the same reproducible Nix builds for your actual project code? So in this example, Nix packages gives you a lot of helpers to make this easy. So for example, we can just point at our source code for our front end and our back end and use these special builders for building Node packages and building Rust packages. And that's all it is. This is just the build. There's a lot of, I think, fear of people using Nix because you get crazy errors and everything is kind of confusing. And that can definitely happen, but there are a lot of cases where you can just do simple builds and things just work. The one caveat of weirdness is these hashes. So in Nix, like I said, there's a sandbox for everything. Nix restricts the networking that builds can do, so that way it doesn't just fetch random things without you knowing. So to allow network access, you have to specify the hash of anything you're downloading. That way, if it works, if I download something and get a different hash, the build will fail. And this is how we force reproducibility while still letting network access as you might need. And this is all sick. This is great. You have builds locally now, but how do we actually deploy these guys to an actual production server? While you could turn this into Docker containers and then use normal orchestration tools that you might be used to, Nix has even a cooler feature that makes deployments very simple. Nix has an idea of a Nix copy. So that basically takes a build on your machine from your Nix store and sends it to a remote machine. And since it knows the full closure of every build, it'll only send the things that machine doesn't have. So say you're iterating on a build over and over again, you can just send the top level build, just the binary, and even though it already has all the shared libraries. And this is kind of sick. It gives you the same kind of power of static builds for anything that Nix is building. So a really common approach that I use when I'm iterating on something is to Nix copy a binary to a server and then just SSH in and run it. And for a lot of projects, this is a really great development loop. You don't have to git clone on that server and do your whole build process or push containers to a registry. It all just kind of works using cool primitives. It really harkens back to the good old days when you could SCP some PHP files to a server and then a website was live. It's very, very awesome. And this gives a really cool extra benefit as well on top of this. You can use this same tooling to get a build cache for free. Basically, you can have a CI server run builds on every commit, push that up to S3 as like a little binary cache, and then all of your developer machines can trust that binary cache, and anytime Nix will do a build, it'll be like, hey, cache, you got it? Cool, send it my way. That way you don't have to eat, a potentially hour-long Rust build just because you wanted to pull the project. So that is kind of where most Nix guides would stop. You have NixOS to get your whole system, and you have Nix shells to manage your repos and some basic builds. We have builds for all of our services. It's locally reproducible, all declared in code, and it kind of just works. And that is sort of true, but I think there's a problem that a lot of Nix guides will stop at, and that's that scripting is still annoying. We have all these tools installed on our systems to get our programs built, but that's only like half the battle to get some software system working. We need to make sure that all of the logic surrounding and running our system and deploying it is actually reproducible as well. So for a little example, this is just a screenshot from the Kubernetes repo where they have a directory called hack, and it's a bunch of little scripts and developer tools that they have in there. So there's a lot of things in here. There's like spin up a local cluster, update docs, run code gen, lint, and run tests. And having these things as scripts is obviously miles better than having a README that you're copying and pasting from. But there's implicit dependencies these scripts might have. Say, they use some random tool, so you might have to remember to update your shell next to put that tool in there. And while they're all at least in one directory, like Kubernetes at least had the foresight to do that, I've been in many, many projects where scripts are scattered all over the place and it just are a discoverability mess. And there's no there's no nice tooling on top. Like many projects will use make or just files or something to kind of organize all these scripts. And it just kind of sucks that it's just one giant directory you have to sort through. So you can kind of address some of these problems with more Nix, right? So you can just write a shell script. Anything in Nix, anything can be a build in Nix, really. So why not shell scripts, right? So we can specify build inputs to this script where we can say, hey, use node and cargo, and you can use the normal things you do. And this kind of works, but then you kind of end up with a Nix shell file with millions of builds just to have all your tools in one spot. And you could be smart and use the Nix language. It is high-level language to organize things, but it just kind of becomes a pain. And a lot of scripts might be doing very specific weird builds. So for example, at Antithesis, we will have certain builds of some of our programs that turn on ASAN or turn on feature flags. And if I'm not really developing those things, if I activate a Nix shell where it tries to do all those builds, that just kind of sucks that I have to eat that cost. Nix at its core is lazy. Why can't I have this laziness in my actual development loop? And so at Antithesis, we kind of took this idea and made this idea of a command set. And all it really is a Nix-based CLI framework that is just a wrapper around Nix builds. And we add some extra niceties on top to get autocomplete and help text and all that good stuff. And it's just little bash snippets, and we sandbox it all to give even more and more reproducibility. So at its core, you can specify a command set just like any other Nix build, and you get a little dev CLI you can put in your shell. And to define your builds, you can have a little organization of, at the bottom, you can define a command. We have a little helper. You write a bash script, and it just kind of works in 3 lines of code. And you can do sandboxing to wrap each script. And in this case, we're just setting the path, because even though Nix will add things to your path, we don't know what else is there. So we might want to restrict it to just be what we know. To kind of go into more in the sandboxing, at its core, again, sandboxing is our main way to give reproducibility. We want to lock down what is wrapped around each of these scripts. We don't want it to see more of your file system. We want to only see the parts of the project that matter. And we might even want to do some network isolation or anything like that. But we can also do the kind of boilerplatey things in this function. We could fetch credentials or look up different things from AWS. And we can kind of recreate Docker from first principles. You can use tools like Bubble Wrap or Pasta to do more isolation from these commands. And it's just a really powerful thing to have the generic sandbox that you can wrap any command in. And you can take these kind of basic kind of scripts like I was showing before and organize them in much nicer ways. You can even namespace them. So in this case, you can run dev test front end to run your front end tests and dev test back end to run your back end tests. And while these are very basic examples, it is nice to have them organized and not in some giant README. But you can have some more complicated examples all for free. So this, you don't really have to care what is actually happening, but this is a tool we have that helps us inspect Podman images. At Antithesis, we work with a lot of containers from customers, and it can be a pain to see what is actually going on. And internally, many people had sent messages around on our messaging platform to how to mount a container and get a REPL in there. But it was kind of a pain that you had to remember and copy-paste all these commands. But with Nix, you can just make a very reproducible script that they can just specify a Podman ID, and all of this magic happens. It's even building an inner script in line, and you can do as many complicated builds as you want, and you have all this templating power of Nix to make it work. And we have a lot of tools at Antithesis to make this happen. For other kind of tools like this, we can attach GDP to our different services, do up heat tracks, do live reloading of our front end. Basically, all of the random kind of things, Nix just makes these tooling a lot easier. And while these examples were kind of like dev and testing kind of things, you can also just do the full serving of our app. So we can use the same builds we already had for building our front end and back end, and just hook them up to use the same reproducible builds in the actual running of our scripts. This way, you're not relying on someone's like node modules or cargo or crates directory. Everyone's using the exact same builds to run the app. This is the exact same builds that are be running in production. And I think one of the surprising things about this kind of setup of how easy it is to make different commands and scripts is that people made ones I wouldn't expect. So at work, we have a little command someone made. We are all in office, and there's a metro station near our office. So someone made a nice command to just say when a train is coming. And I would have never expected that our tooling to do our reproducible builds and to serve our different services would be so easy that people are now hitting our metro API just for fun. So where are we at again? So now we have our builds working. We have our reproducible builds. And now we have a declarative CLI tooling and a fully reproducible runtime for all of our scripts. But we have yet another problem. And that is that deploying a distributed system is really hard. Obviously, there's the normal distributed systems problems of like network faults, machines dying, and network partitions, anything you can think of. All of those are still real and still a pain. And if you need help with that, come talk to us at Antithesis. But what I want to focus on is how you actually deploy them. And there's a lot of deployment pains when it comes to deploying distributed systems. In a distributed system, there's not like one version of it all. You might have a multi-repo setup, so you never quite know what is all deployed at once. Locally, I might be developing with a certain checkout of all these different services, but I don't quite know if that's what's going to be deployed. If you're doing rollbacks of individual services, I may have not tested that combination locally, and it can be kind of a pain to reproduce exactly what happens in prod locally. I think one of the more annoying ones that I think is a fairly hot take is that cross-cutting changes are really tedious for no reason. Like API contracts are lies and they cannot hurt you. What I mean by that is like I have a few services. Why do I have to care about backwards compatibility because they might be deployed in random orders? I have a monorepo. I see all of the services on my checkout of the code. Why can't I just deploy them all at once and not have to care that I'm breaking in this weird state? And I think this is kind of taking over a little bit in like the TypeScript, JavaScript world where like things like Next.js and Svelte and all that stuff have all these server-side functions because people just hate having to think about that. They just want to look at the code and know that the front and back end is going to be talking the same language. And finally, it's just kind of hard to reproduce the exact state. If something goes wrong in production, I have to look at each service and then say, oh, it's running this version or this version and this version. And it can be a pain to know how I can actually reproduce that. It'd be really great if there was like a first-class way of saying this ID is what is deployed in production. But we kind of already solved that for a local deployment, right? Or local development. We have this tooling here to run our overall Nix builds in a very consistent way. So, we're using all of these reproducible full builds to run the front end and back end locally. Why can't we take this same tooling and use it in production? And at Antithesis, we do kind of have a solution for that. And that is what we call like deployment manifest. So we can take and wrap those commands, we build them all, and track each command in a little JSON file. So for example, we build the full front-end thing with its sandbox and the full back-end and with its sandbox, and track the Nixdoor paths in this JSON thing. And we can upload all of these builds to a little binary cache, so that way everyone shares all the builds. And we can take a hash of this deployment to get a deployment ID. And we can upload this JSON to a little registry. And so if we can, I'll just show you an example at least. So basically, we have a little service that can orchestrate and create this entire deployment. So a request will come in with an ID. It'll look up that ID in our deployment registry to figure out what the JSON of each command it needs to run. It can then spin up empty boxes and tell it, hey, you're running the front end, here's the Nixdoor path. You're running the back end, here's the Nixdoor path. And each of those guys can then fetch from a binary cache to get all of the closure. So they'll be able to Nix copy basically the entire closure of what they need and run it from scratch, basically. And what's cool about this is that each machine here knows its full deployment. So it could, for example, spin up more backends if it needs, or spin up a random batch process background running job, all shared in the same deployment and be consistent. And what's really cool about this is that if you need a new service, say you need a new backend service, or you're spinning up another database or anything, all you need to do is add another bash script, throw it in that command set. It'll get put in our deployment JSON, and all of the same infrastructure would take over. And all of this is deployed in a very consistent way. We have a JSON manifest for everything in here. And this is all sick and great, and it does work as a really nice deployment mechanism. But one of the unintended benefits of this is that you can have multiple copies of all of our services running with the same underlying infrastructure. Because each deployment is fully self-contained, it's only talking to other things in its same deployment, you can trust that it's all fully isolated from each other. And at Antithesis, this has been super, super powerful. All of our developers can develop in a production-like environment and not have to worry about clobbering each other, because we're all can develop locally and use these same primitives to deploy in production with the same amount of pain. There's basically zero. And we can, since we're developing in production, we are very confident that when a customer starts to use these different builds that we're using, we have used it in the same environment, so we're fairly confident that it's going to work for them. And what was really cool about this is we realized that we have a content address URL for each of our things, so we get things like branch previews basically for free. And basically, if I wanted to have you take anything away from this, is that we have reproducibility all the way down on our stack. So Nix builds tells us what runs, command set will tell you how it runs, and our deployment manifest will tell you what runs together. And all of these are explicit. It's using the same process for your local machine, in CI, in a preview environment, and in production. They're all not using separate configuration languages, separate tooling. It's all the same thing throughout the whole stack. And this level of reproducibility and confidence is super, super awesome. Developers, since they have this confidence that things are just going to work, they can try out new tools, they can break a whole API contract, they can do whatever they need to do just to see something working in production. And basically, the more you make your processes reproducible, and your developers can focus on the things that matter, and that is making your software actually work and not have to worry about all of these different pains in these deployment processes. So with that, any questions?
Good talk. I'm also a fan of Nix. I am wondering about channel versions. So one source of impurity in these is the specific Nix package version that anyone installs when they run Nix shell. Do you pin that?
Yeah. So in our repo, we have like a file of like, hey, here's our golden pin, and that way we know everyone's using the exact same thing. Yeah.
Cool.
Mm-hmm.
Hey, thanks for the talk. This is a bit of like a practical operational question. So in this example with the back end and the front end, let's say that we also have a database. And let's say we do a schema migration and add a column to a table. And then all of a sudden we realize, actually, no, we got to roll back. We got to remove that column from that table. How do we, this database is outside of our kind of perfect, pure Nix managed world. Mm-hmm. Operationally, in practice,
How do you handle that?
how do you guys handle that?
Yeah, so at Antithesis, we kind of have two styles. So this deployment style is really beneficial to, we have a lot of long-running kind of ephemeral jobs. So we spin up multiple services for like 3 hours and they die. We still want an API in there and a backend and all that good stuff. But for the things that like need to rely on outside state, we actually did this very recently where we had an API server that had to talk to a database. We basically cut it in half and put the backend that talks to the database outside the deployment. So that's like something managed by like Terraform. That is like sort of long living and managed with a different process. That guy is the one doing schema migrations and all that good stuff. So we only have one layer of like API contract coming into this pure world. It's sort of like, you know, this is a really stupid take, but it's like wrapping your entire deployment in like an IO monad. Like it's pure in here, but over there, this is where the pain is basically.
Makes sense. Thank you.
Semi-related to having to deal with things outside of the Nix golden sort of column, is there any sort of like easy tooling that, you know, I know the Nix like REPL exists where you can evaluate derivations sort of in the shell and see what the actual inputs are to, you know, oh, this evaluates to this awful LD path, you know, and like, is there any sort of like existing websites that make that more intuitive?
In the sense of like debugging a build gone wrong or like just exploring what's going on?
Or like giving developers who have to interact with changing derivations to get to where they need to go. Obviously that's like a very difficult thing.
Yeah,
but
if I said, if there's any #1 complaint with Nix, it's that that is the hardest problem. But how I kind of view it is, at Antithesis at least, there's a few of us who kind of are the Nix heads. And I kind of take us as the pain eaters. We're making this beautiful world for everyone else to have hopefully nice abstractions on top. But with that said, I think the Nix documentation is getting better for this stuff. Its error messages are getting better. I think the last couple years, the Nix community has really, you know, put a lot of work into making this more of a nice experience. So hopefully that kind of helps. And honestly, AI tools are kind of goated to Nix because it's so declarative, and it does make it a lot easier.
consult the oracles.
Yeah, basically. Yeah.
Hey, thanks for this great piece. As you know, as of fiscal year 2023, all developers who insist on reproducible solutions were left behind. So I'm wondering if you could account for your continued existence. You don't have to take the bait if you don't want to.
Hello.
I honestly have no idea. I guess, you know, reproducibility everywhere. Why not? Yeah.
Okay, thanks for the talk. I'd like to ask you something. What is, are you running on a specific distribution such as NixOS, or do you Nix only the Nix package manager on a distribution of your choice?
Oh, say again, sorry?
Are you using NixOS for doing all your configurations, or NixOS?
So like we use a lot of, like, at Antithesis, everyone has a NixOS config for their system, at least if I'm understanding the question correctly. So there's like Nix packages, and NixOS. So like Nix packages and Nix is kind of like the build system and package manager. And that can be used on a lot of different machines. It can be used on Macs or Linux or whatever. And NixOS is, you know, the full distribution. So you're bought in, you're all on Nix, you know, on Linux, configuring your system that way. Was that kind of what you're getting at?
Yeah, exactly. That was the question. Just, I was wondering whether all this setup is applicable to, let's say, ordinary distributions such as Red Hat, Ubuntu, or anything else.
Yeah, you can use, basically, most of the tooling in our repo itself could technically be used on other distributions. The fact that we're on NixOS does help a little bit more, but you could even do this on a Mac, kind of. Then there's even like NixOS-like things on Mac called like Nix Darwin to give you the same kind of power. There's a lot of tools to kind of give this same vibe on a lot of different systems.
Okay, thank you very much.
Related to that question, maybe you're familiar with this tool. We use the SaltStack project to configure our remote Debian-based systems. is NixOS and its related tooling something you can just swap out for building and configuring these production systems with our release code? Or?
I'm not sure what the salt stack is.
Okay, it's
It's like Ansible. Yeah, okay,
Yeah,
it's
yeah.
similar vibes.
Yeah.
So like what we do is we have NixOS for all of our like cloud boxes, like our AMIs, and so that gives us a fully reproducible like build of a thing, and then we rely on Terraform to kind of spin up the long-lived infra, and that's the kind of magic between.
okay. Thank you.
Thanks for the talk. I'm curious if in your setup you've had any sort of problems or experience with like performance, especially for incremental rebuilds. Like I know that build systems and big monorepos typically sort of have a lot of effort in having fine-grained action graphs for the builds, and I'm curious if that's sort of how that works in Nix. And
Yeah, it can be a pain. Like a lot of the little helpers I point out are a lot of the more basic Nix builds. They'll kind of wrap the entire Rust build in one derivation. So if any of your dependencies change or any of your source code change, it builds like all of its dependencies again. There's a lot of tooling, each specific for certain languages, to kind of split it up into multiple builds to make that more and less of a pain, or less of a pain. It depends on the language how good the tooling is. For Rust, there's a lot of things that make that nicer, but it's just kind of a little bit of a grab bag at the moment. And I think the biggest pain as you get a bigger and bigger Nix repo is that the evaluator is really slow. So the Nix evaluation language is very old. If you ever have to look in the source code of Nix itself, it's some of the most spaghetti C++ I've seen, so it needs some love to be more performant. But yeah, that's honestly the biggest drag for Nix at scale.
I'm curious, what's your like typical build time look like?
A typical build time?
Yeah.
It depends, right? Like, a lot of the time it's like the underlying build itself. Like, if you're building Rust, it's going to take a while. If you're building a lot of C++, it'll take a while. So the evaluation, it can be long. I think for like everything in our repo, it's like 2 minutes to do a raw eval, like to build everything. But then the underlying build just depends on the language.
Thank you.
Hey, so I don't think I understood how you're using Nix to solve the backwards compatibility problem when you're pushing. Like, because even if you have the system that perfectly describes the state that everything has to be in, like, you still have to make sure those push at the same time and things cut over at the right time, and in-flight requests still use the version that started on. So yeah.
Yeah, so at Antithesis, we kind of have it a slightly easier. This was a simplified example. So we do a lot of like ad hoc like spin-ups of multiple systems at once. So like we do test runs of your software. When this test run comes in, we'll spin up like 4 different services at once just for that test run, and then that's kind of a pure kind of thing. For that kind of failover, we can still use like load balancers or like auto-scaling groups in production and load balancers for like the long-lived infra as we do that. Kind of similar vibes. So that pain is still a little there, but for us, we have it slightly easier in some parts of our stack.
Gotcha, yeah.
All right, give it up for John. Thank you. Yeah.